future physics students, and welcome to a video about circuits. Now, circuits is something that is definitely going to be on your semester 2 final, and you're going to have to know a lot about. And this is a video to explain the basic 101 of what to do. I hope that this is going to be a great help to you, because I know I had a little bit of trouble with circuits. So without further ado, let's get started. So first thing we have the light bulb. This part of the light bulb is called the screw, and this part of the light bulb is called the nub. You'll need to remember these for later, because that's how you're going to make your first circuit. In order to build a simple circuit, you'll need a wire, a battery, and a light bulb. The first thing you do is take one side of the wire and attach it to one side of the battery. Put the other side on the screw of the light bulb. Then, touch the light bulb to the other side of the battery. The bulb should light up, as you can see. With the physics equipment, you want to make sure the battery is first in a blue container and that you have the alligator crocodile clips, the light bulb holders, and the light bulbs. To make a simple one bulb series, you'll first want to attach the alligator clips to each of the little terminals on the battery holder. Then attach the other sides to each of the parts sticking out on the light bulb holder. The light bulb should light up. If you want to add more bulbs to a series, all you have to do is add more wires and bulbs as needed. It's as easy as that. Once you've added more bulbs to the series, you should see that each one is dimmer. We'll go over why that is later. To make an easy parallel circuit, all you need to do is add 2 more alligator clips to either side of the first light bulb stand, then attach the other sides to a second light bulb stand. The bulbs here should be equally bright, which we will also go over later. Be careful when you're doing this to not short circuit the battery. You can tell if the battery starts to get hot, smoke, or glow. If it does, stop and break the circuit immediately. To draw circuits, you need to remember 3 symbols. This one is a symbol for battery, this one is a symbol for light bulb, and this one is a symbol for resistor. Here is an example of a drawn circuit. Based on the things we have gone over, we can conclude 6 statements that are always true about circuits. These are called the 6 circuit cornerstones. The first is that current is consistent throughout a series circuit. Each light bulb gets the same amount of current, explaining why they are equal in brightness. The second is that a parallel circuit is an independent one, meaning that unscrewing a light bulb will not affect any lights parallel to it. A series, on the other hand, is a dependent circuit. Unscrewing one light bulb will cause an open circuit so the others will go out. The third is that current will go a path first depending on how close it is to the battery. This is in the case of a parallel circuit. The current will first go to the closer bulb, then the others. The fourth is that if you add a light bulb in series with a battery, it will increase the overall resistance of the circuit, meaning there will be less current going through the battery. This explains why light bulbs in series become marginally dimmer the more there are. The fifth is that if you add a light bulb in parallel, the overall resistance of the circuit goes down, meaning the current goes up. There needs to be more current here in order to keep the brightness of the bulbs consistent. The final cornerstone is a simpler way of remembering 4 and 5. The more resistance in the circuit, the less current running through the battery. Meanwhile, if there is less resistance in the circuit, there is more current going through the battery. Less resistance, more current. Less current, more resistance. It's easy. As just a practice, if you were to unscrew B from this circuit, what would happen to C? I'll give you a little bit of time to think about this. If you said that C went out, you're right. B is in series with C, so if you were to unscrew it, it would create an open circuit, meaning that C would go out. A, however, would stay the same, because it's in parallel with the circuit. A resistor is kind of like a substitute for a light bulb in a circuit. If you were to use a resistor, all you would need to do is plug it in instead of the other light bulb stands. Resistors are a way to measure the amount of current in one thing at one time. An ammeter is a device that we use to measure the amount of current going through a circuit at one time. The way to do this is by plugging in the wires extending from it to alligator clips in series with the battery. If you did this right, then the meter should go up. You can plug it into different sensitivities going down towards the black to get more sensitive readings, which are also more accurate. Be sure to consider significant figures, however, when doing this. Another rule you'll have to know is the node rule, or Kirchhoff's junction rule, which states the current through each resistor or bulb must add up to equal the current of the battery. For example, if you had 2 bulbs in a parallel circuit, and there were 3 amps of current going through the battery, and you had 1.5 amps of current going through one of the light bulbs, then the other light bulb would also have 1.5 amps because it has to add up to equal the 3 amps of the battery. A voltmeter is similar to an ammeter, except we use this to measure voltage in the battery. In order to use this, you have to plug in the wires extending from it in parallel with the battery. Usually you can just hold these to the alligator clips. Again, you're doing it right if the meter goes up, and going down towards the black will give you a higher accurate sensitivity reading. The rule you'll have to know for voltage is the loop rule, or Kirchhoff's loop rule, which states that all voltage across a circuit loop must add up to the voltage of the battery. For example, if you had 2 bulbs in a series circuit and the battery was 9 amps, and one of the light bulbs was 4.5 amps, the other light bulb will also be 4.5 amps, so that it can add up to the original 9 amps. On your test or quiz, you'll be asked to find the current, resistance, or voltage of something in the circuit. When you do, you'll want to remember this following equation. Voltage equals current times resistance, or V equals IR. It's pretty easy to figure out what you can solve in terms of whatever. However, you'll want to remember this. The units for voltage is V for volts, current is A for amperes, and resistance is the omega for ohms. Another common problem you'll have in this unit is to find the equivalent resistance of a circuit. As you can see here, you have a circuit with a 3 ohm resistor and a 6 ohm resistor in parallel with each other. To do this, you're going to want to refer to some equations. In the case of a parallel circuit, you're going to want to do the equation R divided by N. R in this case stands for the equivalent resistance of one resistor, and N is the number of resistors in the circuit. In the case of this problem, we're going to want to make it so that all of the resistors in the circuit are equal to each other. And here's how. First off, you have to draw a circuit so that all of the ohm resistors will have to be the same number. In the case of a parallel circuit, 2 6 ohm resistors will equal 1 3 ohm resistor. It's like factors. If you had 3 6 ohm resistors, it would equal a 2 ohm resistor, and so on and so forth. In this case, you'll have to have 3 6 ohm resistors total because there's also a 6 ohm resistor in the circuit already. And to find out the equivalent resistance, you'll have to use the equation for parallel. R parallel equals to R over N, which is equal to 6 over 3. All in all, it should be equal to 2 ohms total resistance. And that's it. Of course, there is a lot more to be done here, but this is basically the gist of what circuits is all about. I hope that you found this video educational and that it will help you with your next test and quiz. And, well, finals, of course. Good luck!
Eva's artistic instinct.
I don't think that's how it works. Well, it is now.
That's not how you draw a circuit, Joel.
That's a light bulb.
Oh!
Magic.
Glory to the newborn king. Okay.
Hey, it's a light bulb! Woot! Can we have that in there?
Sophie.
What?
Sophie.
What?
You pressed the button and it said recording.
Did you not record it?
Yeah, it's a light bulb.
Here, wait.
No, it shows. Joel.
That's
Joel,
good. That's
Joel,
good.
Joel.